Let's attempt question 7 of the 2022 O-Level A Math Paper 2. Two countries are separated by a border that runs from west to east. Villages A and B lie on the border, so this somewhat shaded part in the diagram is the border. A helicopter flies 30 kilometers from village A to a village C. So along this entire line. Angle BAC is theta. The helicopter then travels 20 kilometers to a village D at an angle of 90 degrees to AC. Okay, so CD is perpendicular to AC. You can assume that the helicopter always flies at the same height. For part A, show that the shortest distance of village D from the border is 30 sine theta minus 20 cosine theta kilometers. The shortest distance from D of village D from the border. Okay, let's just zoom into the diagram here a bit. So let's analyze this diagram. So the shortest distance between D and the border would be this height here, right? So let's just assume this is a vertical line drawn from the border to D. Okay. So this is the shortest distance that we want. Let's just change, or rather annotate this diagram a bit. Yeah, I'm going to draw a vertical line from C all the way to the border. And then a horizontal line from D due west of D. Okay, so we know this will have to be a right angle, right? So the purpose of doing this is to create some right angle triangles. And you know, this will also be a right angle. Okay, so now what can we see from this diagram? So this angle here, okay, let's annotate first. Let's annotate the diagram first so we can refer to the lines and angles a bit more easily. All right, so this angle, let's call it angle XCA. Okay, we know that it will be equal to 90 degrees minus theta, right? Because we already have theta here. So, and you have a right angle. So the remaining angle must be 90 minus theta. Okay. So this will be important y later. So this is 90 minus theta. So this remaining angle here is what you get when you have the right angle ACD, so 90 degrees, minus 90 degrees minus theta, which is XCA. Okay. And if you were to expand that, it's just 90 degrees minus 90 degrees plus theta. So it's just theta. Okay, so angle DCY is just theta. This will be important later on. Okay. Oh, actually, let me just leave the annotations here. All right. So let's attempt the question. So from this question, we know that sine theta, looking at triangle XCA, right? Sine theta, sine, remember, is opposite over hypotenuse. Okay, so sine theta. The opposite will be XC. The hypotenuse will be 30 kilometers. So we know that XC is equal to 30 sine theta. Okay. Then angle DCY is theta. So YC, okay, let's start with cosine theta first. So cosine theta, okay, cosine is adjacent over hypotenuse. So the adjacent, if your theta is DCY, your adjacent will be CY, okay, or YC. So cosine theta is equal to YC over hypotenuse, which is 20 kilometers. So YC is equal to 20 cosine theta. So why did I find XC and YC? Because if I want to solve for this vertical distance, right? Okay, which is the shortest distance from D to the border, then I basically just have to find the difference between XC and YC. Okay. So therefore, the shortest distance is just XC minus YC, which is equal to 30 sine theta minus 20 cosine theta. Okay. Then in the next question, express 30 sine theta minus 20 cosine theta in the form r sine theta minus alpha, where r is greater than 0 and alpha is between 0 and 90 degrees. Okay, so you know for this question, you have to use your R formula. So the R formula is not given in the exam. You have to memorize this. So just take note of that. So let's just recall the R formula. For the R formula, we have A sine theta plus minus B cosine theta equals to R sine theta plus minus alpha. So this is the form that we're going to use. And R will be equal to square root of A squared plus B squared. And alpha is tangent inverse B over A. So the good thing about R formula questions is, even though it's hard in the sense that you have to just memorize it, okay, if you don't memorize it, then there's no way you can solve the question. Okay, even though it's hard in that sense, but once you memorize the formula, you just have to substitute the numbers in. Okay, it becomes actually very easy. So try to score for this kind of questions. So let's apply the R formula. Okay, so your A, you can just compare, it's 30. Your B will be 20. Okay, so R is equal to square root 30 squared plus 20 squared. And it's square root 1,300, which is 36.056 to 5 SF, or 36.1 to 3 SF. Okay. And tangent, so alpha is equal to tangent inverse B over A, so 20 over 30. That is equal to 33.690 to 3 dp. Okay, but for angles in the final answer, we leave it to 1 dp. This is just for the final presentation later on. Okay, so therefore, 30 sine theta minus 20 cosine theta is equal to square root of 1,300 or you can actually leave it in the rationalized form. So this is 10 square root 13, or a simplified form, I mean. So 10 square root 13 sine theta minus 33.7 degrees. Part C, find the value of theta if village D is 10 kilometers from the border. So notice the expression we just found. That is basically the distance between D and the border, right? So we can just equate that to 10. So 10 square root 13 sine okay, let's use the intermediate answer. Okay, this is equal to 10. So sine theta minus 33.690 degrees equals to 10 over 10 square root 13, which is 1 over square root 13. Okay. So the basic angle of theta minus 33.690 degrees equals to sine inverse 1 over square root 13, which is 16.102 degrees. This is to 3 dp for the intermediate answer. Okay, now we know the basic angle. So recall from the question, right, the theta, because of how the diagram is drawn, you know that theta is between 0 and 90 degrees. Okay, it has to be an acute angle. So the range of values we're going to consider for theta minus 33.690 degrees is, we're just going to minus 33.690 degrees from the upper and lower end. So yeah, okay. So this is just the range that we're gonna look at. Okay. So why is this important? It means the angle, the theta minus 33.690, we're only going to be interested in values that will give us the value of that angle as being between this and this. Okay, so it's a pretty small range, right? You can see. So when we draw the ASTC diagram, okay, because we have sine and it was a positive ratio, 1 over square root 13, we will look at these two quadrants. Okay. So if we start from the 0, okay, because we can see negative 33.690 degrees will be in this quadrant, right? But we're not interested in any angles from that quadrant. Okay, so we just go straight to the positive. And we will only consider the first quadrant. Why? Because for the second quadrant, we can see this is already bigger than the higher end, which is 56.310 degrees. We're not interested in any angles greater than 56.310 degrees. So for quadrant 2, we are actually not going to look at that angle. Okay, so we are only interested in one angle, which is the basic angle, 16.102. So therefore, theta minus 33.690 is equal to 16.102 degrees. Only this one. And your final answer for theta is just 49.8 degrees. And this is the final answer, so you can just leave it to one decimal place.